Hello everyone. In this course, we will continue examining IoT industry applications and solutions. In this section, I will describe the development trends of IoT applications based on some emerging technologies. In the previous courses, we learned that IoT technology covers a lot of content because different technologies are used at different layers of the IoT. For example, at the network layer, we use communications technologies such as 5G. At the platform layer, we use technologies such as artificial intelligence for data processing. Many other emerging technologies are used in the IoT field. Let's learn about 7 emerging technologies first, which can be called 5I, ABCDE for short. What are the technologies represented by these letters? 5 stands for 5G, and I for IoT, A for artificial intelligence, B for blockchain, C for cloud computing, and D for big data, E for edge computing. These 7 technologies are popular. All of them are used in IoT application scenarios. In today's course, I will use several popular technologies as an example to explain the development trends of IoT applications. For example, let's talk about 5G and edge computing. These 2 technologies can be applied to the IoT. We will explain them in detail in the following courses. In addition to providing ultra-high transmission rate, 5G can provide ultra-low latency for things in the IoT. Edge computing can also greatly reduce network latency. How do these 2 technologies provide services for the IoT? In the IoV scenario, these 2 technologies can provide low latency services for assisted driving or automated driving. In the IoV, low network latency is important. If the network latency is too high, when there is a risk of collision, vehicles may not brake in time and accidents may occur. The same requirement needs to be met in remote surgery and industrial manufacturing scenarios. If the latency is too high during remote surgery, doctors' operations cannot be displayed quickly enough, which poses risks to patients. Furthermore, in the high-precision industrial manufacturing field, a difference in 1 mm can have a great impact. Therefore, we need to use low-latency networks on technologies for remote control. We use a combination of 5G or edge computing technology and IoT. In addition, we use technologies such as big data, cloud computing, and AI. These technologies and the IoT are related to each other. We can use a human body as an example. The IoT is mainly responsible for data collection. It functions like sensors organs of the human body, such as the eyes, ears, and nose. We obtain data using big data technology. We store the data in the cloud, which use cloud technology. At the same time, AI technology, which is similar to the brain, is responsible for decision making and control. The relationship between big data, cloud computing, IoT, and AI is as inseparable as different parts of the human body. Among the 4 technologies above, AI and IoT are closely related. The combination of AI and IoT is called AIoT. The data collected by the IoT can be used by AI, and a massive volume of data is what AI needs most. The 2 complement each other and can provide us with more intelligent services. Currently, the implementation process of most IoT projects integrates AI, We are in increasing need of AI-based decision-making. AIoT technology is no longer optional. In the future, IoT solutions that do not integrate AI capabilities will become increasingly less competitive. In addition to the new technologies mentioned above, I will introduce other new technologies such as quantum computing. Although quantum computing cannot replace traditional computing in the short term, its prospects are bright. It is the future of computing, solving many problems that traditional computing cannot, such as database search, large sample simulation, and machine learning. As an analogy, traditional computing is a car, and quantum computing is a rocket. What does that mean? Although the rocket is very fast, it cannot be widely used in our daily lives. Only when our living standards reach a certain level can rockets be used as a means of transportation. The same is true with quantum computing. It can only become widely used when we have developed other technologies to a level similar to that of quantum computing. There is also digital twins technology, which will be described in subsequent courses. Simply put, it is a simulation process of obtaining data using sensors and physical models. It completes mapping in a virtual space to reflect the full life cycle management of the corresponding entity. What does this mean? It means that we can use data to present our products in the virtual world. For example, currently, O&M personnel cannot monitor the status of a high-speed train after it leaves the station. Digital twins technology can construct a model on a computer based on the train data, so that O&M personnel can view the running status of a train. Digital twins technology can also be used in applications such as industrial IoT and smart city to build models for better O&M management. That's all for IoT application development trends. Now, let's make a brief summary. In this course, we learn about several common IoT application scenarios at the application layer, such as smart city, smart campus, smart grid, and IoV, and industrial IoT. In the smart city scenario, there are several small application scenarios. We learned about the challenges faced by various industries and the changes that digital solutions can bring to these industries. We also learned about the 7 emerging technologies of 5I ABCDE, how these technologies should be integrated into the IoT, and future development trends. That's all for this course. In the next course, I will introduce IoT security for you. Security is something we need to pay close attention to when developing technologies. It is particularly important in the IoT field because IoT devices may suffer from various security attacks. Therefore, we need to use appropriate methods to handle security issues. In the next course, I will introduce the security threats to the IoT and how to handle them. Thanks for your watching. See you in the next course.